Welcome everybody to the third session, live session with us in our office hours. Welcome to week 6. I hope you guys are pumped. We're over a third of the way through the class. You guys are doing awesome, fantastic work. We couldn't be prouder of the hard work that you guys are putting into this, and all the great feedback that you're giving us in the discussion forums. And all the discussions you're having with each other, it's absolutely fantastic. And we couldn't be more excited to be working with you guys and having such a good time doing it. So our first question says this person was working on the tree challenge. And in this question, they were asking how they get the stars to be aligned in between the spaces on different lines. So what I'm going to do is we're going to switch over to the code view, and I'm going to walk through my solution and how I solve this problem, and we can see how it works. Sorry.
It's all right.
I got to get all my pieces. Okay. This. Oh, screen. Entire screen. Okay. We're on that one. And where'd Python go? These guys?
But you're still going to have to say share screen.
Oh, I am going to say share screen. Okay. Woo!
Whoa!
That looks fun, doesn't it, guys? All right, here we go. Let's fix that. Okay. So we got a little bit of recursion there. All right. So this is my solution, and it starts off with the size variable here at the top. And this size variable represents the size of the tree that I want to make. And then I've got a series of print statements, and each one consists of the same 2 pieces. First, there is a space multiplied by the number, right? So there's a number here, and this number is always, these are fixed, right? So what I'm doing is using string multiplication to do the leading spaces for the top of the tree. And I do this because I want them all to be pushed out towards the middle. So if I have up to 10 rows, I'm going to replace these. If I have up to 10 rows of stars, I want to put those 10 spaces out in front of the first star. Then I string concatenate that with a star and a space multiplied by size minus 10. So if I have 10 times size minus 10, that's going to give me 0, and this row is not going to be printed. That star is not going to be printed. It'll be empty there, and it'll go down the rest of the way, right? So I've got actually 11 of these things all through here because I've got 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's the bottom row down there. So I can actually make something that really works for 11 rows on this thing. Now, as I increase here, this pulls in where the stars are printed, each space, 1 space on each line, and then I determine here. So the trick here is that for trees smaller than 10 or 11, if it comes out to be a negative number or 0, the asterisks aren't printed. They're just removed. It doesn't work because -1 times an asterisk doesn't mean anything. I can't do negative quantities of a real thing. So the string concatenation operator just says nothing. There's nothing there, and it just prints an end line. So if I do 10 and I run this, yes, please. I hope I didn't overwrite something. Then I've got all of my stars, and you can see there's a blank line here. That's the first line, and you can see all the spaces that it printed out. Then there's the second line. There's 9 spaces, then a star, then a space, right? So that space is invisible, but it goes there. And this is how it makes it in the middle, in between them on each row. So I did 8 spaces. So it's only one. Then first star is only 1 space over, so that the space that it follows it from the string printing is below the one in front of it. So I'm not doing a half space or anything like that. That's not possible. It's just offset a little bit so it prints all the way down. Now, if I go back over here to my code and I make this 5, when I run it, also hit save, notice I've got a whole bunch of blank lines, so I'm kind of cheating. here. I've got a whole bunch of blank lines, and then I've got my 5 rows of my little star tree here that follow that same pattern. And really what's happening is I'm doing the same, it's the same subset. So you can kind of see there's a 5 tree in the 10 tree, but I'm not printing all of the extra stars at the end of those. So I'm only printing out those first few because these all don't get printed, and I start printing out here. So size -5, that'll be 0. Size -4, that prints 1. Size -3, that prints 2 stars. Then 3 stars, then 4 stars, and finally 5 stars for the bottom, right? So that's how I did it, and I just wanted to share that with you guys and see how that works. Okay.
So just worth noting too that next week when we start on structured programming, we'll see how we can do that same kind of thing in 2 or maybe 3 lines of code, and do it for an arbitrarily sized tree. You know, anywhere from 0 up to hundreds of lines tall.
Yeah. This sequence and the functions part we haven't yet touched on some very powerful components of the language that you'll see next week, which is going to be super exciting.
All right, so the next question was a question about the week 5-6 lesson, and it asks, assume that we have 2 fairly complex programs, program A and program B, and both programs are functionally equivalent. They both produce the same output given the same input, yet one program uses user-defined functions and calls those functions, and one program doesn't use user-defined functions. So it's just a straight sequence of instructions all in line. And there's a question about what it means in terms of the computer and its operations executing one of those programs, the program A with functions versus the program B without functions. And it's actually a fairly complex question. And depending on how we focus on the question, we might get slightly different answers there. So if you had a simple program that was a sequence of instructions, and none of those instructions were really repeated, it was just maybe a sequence of 30 separate instructions, we could write a program in which we take the first 10 instructions and pack them inside of a function, and the next 10 instructions and pack them inside of a function, and the last 10 instructions and pack them inside of a function, and then we call the first function, call the second function, and call the third function. We get the same results. Of course, the source code is now a little bit bigger because each of those 10 lines of code for each of those functions is packed inside a function. Then we have to call that function. So the source code becomes a little more complex. And at the same time, the runtime complexity of the program and the memory requirements of the program become a little more complex. In addition to any variables it needs for those 30 lines of code, it's also going to need stack space anytime a function is called, and it's going to have to create a stack frame for that function and manage that. So it's going to be more complex in terms of the source code and more complex in terms of the memory requirements and the runtime requirements of the program as it runs under that set of circumstances. On the other hand, if you were to imagine that I have a set of instructions that I want to repeat a couple of times. So maybe it's these 5 instructions, and I want to execute these 5 instructions 3 different times, but in 3 different places. So maybe I want to execute these 5 instructions, then a few different instructions, then those 5 instructions again, a few more different instructions, and then those 5 instructions one more time. In that case, if I were to pack those 5 instructions inside of a function and call that function in those 3 locations, we would end up with simpler source code, fewer lines of code. So instead of repeating those lines of instructions 3 times and having 15 lines of code, we'd have them in the code once, packed inside of a function with 3 separate calls. So we would get some advantages in simplifying the code, but we would still end up with some additional runtime complexity. It would require a little more memory at runtime for the program to execute. But in general, the computer is very capable of handling runtime complexity. So asking the computer to create stack frames and manage those is a small price to pay, and it's exactly what this thing is designed to do. So there's a big emphasis, and the emphasis in general should be on simplifying your code and allowing the machine to do the work.
Yeah, yeah. And at the hardware level, modern machines are designed to do these function calls. They will have special instructions in the hardware that allow them to execute, to build that stack, to create local variables, to destroy local variables, and to save away anything that's important, and do all kinds of stuff all in one instruction that really only takes maybe a clock cycle or two out of the billions per second that these machines are running at. So these machines are designed to use functions. They're designed to have functions be part of the programs that we write. So take advantage of that. Don't shy away from that. That's not to say that there isn't a performance cost when it really matters, right? But it really matters very, very rarely. If you're talking about individual clock cycles in a function call or something like that, that is basically almost never going to happen in your career. It's a very rare case, and you would have to be trying to squeeze every last bit of performance out of a piece of code that runs in a massively huge machine in order to see any value to not using functions.
If we wanted to go a little further down that rabbit hole, many programming languages and their compilers and runtime environments are capable of doing optimizations. So they can look at that code that you've written that may have functions in it. And so your code looks nice and clean because you've written it with functions, yet they can make the decision when they're compiling or executing to essentially unroll those functions and make the runtime environment faster and more efficient. And so we generally don't have to worry about that. Again, the machine's kind of got your back.
Yeah, totally. Yeah. So this is a great question. It kind of exposes some of the underlying principles and some of the machine that's happening underneath when we call functions. So that was an awesome question to give us. Those are the only two questions that we had posted in our discussion board that we didn't already answer in the discussion board. So we're going to wait just a minute here to get the broadcast caught up, and we'll ask if there's any questions you guys want to ask in the chat room. That would be super helpful, and we will. Other than that, we'll sign off. So I'll wait just a minute here for any questions that you might have last minute live.
We could also do a quick example of this kind of a thing, just pulled out with negative values, just to reiterate the fact. So I'll do that.
Okay.
While we're waiting for any last minute questions, I'm going to just go back to that first question again. And reiterate what was said about using the string multiplication operator with values that might be negative. So first, as an example, if we said that I want a capital X times 3, this unsurprisingly gives us 3 X's. If we take another simple example, a capital X times 0, then this pretty intuitively gives us 0 X's. And so the only really weird case is what happens if I ask for a capital X, something like negative 3 times. And again, it just gives us no X's. It can't construct a string composed of negative 3 X's. It can construct a string composed of 0 X's or 3 X's, but any kind of a negative number, it's just going to give us an empty string. And so that's the feature that this program is taking advantage of here. When size is less than one of these numbers, we're going to get a negative value here, and therefore on that line it's going to print no stars. So it's going to construct a string with 0 of these, concatenated onto, in this case, 9 spaces. Hopefully that clarifies that a little bit.
Awesome. great. So I think that's it for us. It's a short day. Guys, keep up the good work. Everybody keep up the good work. We're, again, super, super happy of all the activity you guys have been doing. And we'll see you in the chat rooms, or sorry, in the discussion boards. And we'll do this again in a couple of weeks.